Okay, today we are going to be looking at the I can statement of I can convert a mixed number to an improper fraction, and also I can convert an improper fraction to a mixed number. We are going to be looking today at mixed numbers and improper fractions. So that's what our notebook page is going to be called. Mixed number and improper fractions. Now you've been exposed to mixed numbers in 3rd grade. A mixed number is when we have a whole and a fraction. That's why it's called mixed, because we are mixing a whole piece of something with a fraction. So if I were to draw a picture of a whole, my whole would be divided into fourths because that is my denominator right there. So one whole thing would be shaded in. And then I also have a fraction of a whole, and there are 3 pieces shaded in on this one. So if I were to look at my visual or my picture of the whole mixed number, I have a whole and 3/4. 1 whole and 3/4. Now, sometimes we have to convert mixed numbers to improper fractions. And an improper fraction is when we have the numerator larger than the denominator. See, my numerator is 7 and my denominator is 4. That means I have 7 pieces out of something that is only broken into fourths, which automatically leads me to think that I have more than one whole thing. Because if I only have 4 pieces and I have 7 of them, that means I actually have 2 things, one whole completely, and then a fraction of something else. So let's go back to my mixed number, because we're going to convert this 1 and 3/4 into an improper fraction, or a number where the numerator is larger than the denominator. And the strategy for this is what I like to call the big C. And that helps me know which direction I'm going in. I start with my 4, which is my denominator, and I take 4 times my whole number. 4 times 1 is 4. Again, see, I'm going in a backwards. I started with the big C. I'm kind of going in a backwards C. I start at the bottom and I'm working my way up to the top. So 4 times 1 equals 4, and then I write that up here. Then this is where my numerator comes into play. I take that answer of my denominator times my whole number, which is 4, and I add it to my numerator, 4 plus 3. 4 plus 3 equals 7. Then my numerator stays the same because I still have fourths. And if you look up here at my picture, 1, 2, 3, 4. This whole thing, remember, is 4/4. 1, 2, 3. 4/4 plus 3/4 is 7/4. So the picture helps to justify the strategy that we're learning. Let's try another one. Let's try 2 and 1/2. Again, let's do the big C. 2 times 2 equals 4. 4 plus 1 equals 5. And my numerator of 2, which are halves, stay the same. Now, if I were to draw my picture, I would have 2 whole things divided into halves, and I'd shade them in. 1, 2, 3, 4. And then I have a half. So I have another whole thing and only half of it shaded. So if we count them all, 1, 2, 3, 4, 5 halves are shaded. So that completely relates, again, to my strategy of denominator times whole number, get your answer, plus the numerator. Now let's walk over here to the improper fraction because it's a little bit trickier. Again, the picture right here matches 7/4. So we can look at this same picture right over here under mixed numbers and know that I have one whole thing and 3/4, which would equal 7/4. But I'm not always going to have these beautiful models, and I'm not always going to be able to draw pictures because sometimes my numerators are quite large. So we have to have a strategy, and the strategy for this is using a fraction as a division statement. So, as we have worked on many times before, the numerator of 7 goes on the inside, the denominator of 4 goes on the outside. Remember, numerator becomes your dividend, denominator, divisor. So again, we could use some strategies here. We can list our multiples to see how many times 4 can go into 7. And I'm going to stop because right now I know that 16 is way bigger than 7. I don't need to go any farther. How many times can 4 go into 7? Well, if I look down here, the closest I can get is 4. 8 is too big. I don't have 8 pieces. I only have 7 pieces. So 4 can go into 7 one time because this, remember, is really just 4 times 1. Okay? And then we use our strategy for division. 1 times 4 equals 4. Then we subtract. 7 minus 4 is 3. So now we're finished because, as you see, we don't have any other numbers over here to bring down. We just have a quotient, a remainder, and a divisor. Now, if you look here, our divisor was our denominator to start. It's going to stay our denominator. How many whole times can 4 go into 7? 4 can go in one whole time, so that is my whole thing. How many pieces are left over? That's your remainder, 3. So 1 and 3/4. And if we look back over here, it matches 1 and 3/4. Let's try another one. Let me move this one up a little bit. Okay. Let's try 11/5. Okay. Again, let's write out our division problem. Remember, numerator goes on the inside, denominator on the outside. So list our multiples, 5, 10, 15. 15 is bigger than 11, so I'm going to stop there. How many times can 5 go into 11? Well, 5, 10. Oh, 10 is closest to 11 without going over. So how many times? Let's count. 1 time, 2 times. So 5 can go into 11 2 times. Then we do our multiplication step. 2 times 5 equals 10. Then we do our subtraction step. 11 minus 10 is 1. And now we have finished our division problem. Now let's convert this division problem right here into a mixed number. How many whole times can 5 go into 11? That is my quotient, so it's going to be a big 2. Now, my denominator, again, is going to be 5 because I still have 5 pieces. What's left over is my remainder, which is my 1. So my answer is 2 and 1